Here we are, looking ahead to future uses of LNG for air and rail. The first term that strikes my mind is the future. Because if this future would be something far away, maybe for the next generation to take care about, we don't need to worry. But this future maybe has already started in some other places of this world. And maybe we are not aware, but it's immediate, and therefore it requires our attention and action. The LNG business started some 60 years ago, not for transport, not as a fuel for transport. It was a mere tool to carry gas in a compact form from the pipeline of the producer to the pipelines of the users. Then, towards the end of the last century, the use of LNG for transport as a fuel started. And we will see, not just for trucks and ships, but also for high-duty vehicles in the industries, for trains, and also for the aviation. But why? Why this change? Why don't we stick to oil? The oil industry and infrastructure is very well established. Why do we have to replace oil? And the answer is in the logo and motto of the NGVA. It's for a sustainable mobility. What does it mean, a sustainable fuel for mobility? To be sustainable, a fuel must have 5 prerequisites. It has to be available, abundant, for security of supply. It has to be clean, friendly to the environment and to our health. It has to be economical to support growth. And then it has to be safe and efficient. And oil had these 5 prerogatives, but in the last century. Now it has lost 3 of them. And what about gas? Gas is clean, about 50% less greenhouse gases emission. This is a combination of lower CO2 emission and nitrogen oxide emission. We know that nitrogen oxide has about 21 times a worse effect than CO2. Gas is available, at least 3 times more reserves than oil. When I talk gas here, I'm not talking just fossil gas. I'm also talking renewable, biogas. Biogas is cleaner than biofuels. Biogas is more available than liquid biofuels. This morning we had a lot of concern about the safety of gas. Why? Gas is not toxic. We even generate gas, methane, in our digestion process, anaerobic digestion process. We use gas in the kitchen, our housewife. Of course, gas is a fuel, and we need training, not only in the industry, which has very good training, but also in our houses, just to avoid the accidents that unfortunately happen. And by the way, gas is less flammable than oil. The ignition temperature of gas is higher, so it does not ignite that easily. And that's the reason why in the dual fuel technology we use diesel as a pilot. The efficiency is another issue. Now, hydrogen and CNG are very efficient per unit of weight, but unfortunately their volume is too high. That's why we developed the LNG industry, to carry gas in liquid compact form. And we will see from the graph that the LNG and oil are very close. Oil wins with regards to volume, but not so much, not even 50% more. And gas wins per unit of mass, about 15%. Now, what is more important, the weight or the volume? That's the problem. Last, the economy, the price, because till the end of the last century, oil price was still in the $15, $20 per barrel. So there was no drive to use gas for mobility because there was no significant price advantage. But things are changing quite rapidly now. Now, particularly in the United States, well, we have seen all these things. The gas price is at least half the price of oil, and this is going to stay. Let's go now to rail and aviation. The race is on. General Electric and Caterpillar are the 2 biggest producers of locomotives. They are already testing use of LNG for locomotives. And if we look at the statement of Lorenzo Simonelli, the GE chief executive, he is convinced that we are entering a new area where natural gas will be a major fuel. Further down, LNG holds the promise of cutting railroad costs, curbing greenhouse gases emission, and leading in the industry's biggest change in fuel technology since diesel displaced steam in the middle of the last century. Now, maybe very few of us still recall the ship steamers or boilers making electricity, but since the 50s, gas has totally replaced oil for stationary industry and also in the ships and in the locomotive. And anywhere the gas pipeline is available, we are not using oil. Another interesting statement. This is 2011 in Russia. A gas turbine-driven locomotive makes the world record of pulling 16,000 tons train in 170 cars. This is about 2 kilometers long. Here in Europe, I was just looking what is the highest pulling train. It's about 3,000 to 4,000 tons. And in the States, I think they reach about 7,000 to 8,000. This is really world record. But what is more interesting here is that the gas turbine-driven this locomotive is an 8.3 megawatt. Is the same turbine that was installed on an aircraft, a Tupolev aircraft, that was flying on LNG in the 80s, 20 years ago, when Norway was starting using LNG for the ships, and when in the States we were having the first trucks using LNG. This plane was a standard. This standard 254, they just took the cabin of the back of the aircraft away and they put a cryogenic tank to test hydrogen and LNG. It made over 100 commercial flights in Russia and even landed in Hanover, in Nice, in France, in Berlin and Bratislava. The collapse of the Soviet Union stopped the program. They were planning for continuation, but let's not forget that at that time there was no price convenience. Gas was not cheaper than oil. Is this program finished? When the NASA last year was asking Boeing what will be the fuel for the aviation industry in the future, now we are talking next generation, they said it's going to be LNG. It's going to be LNG making the power for the internal requirement with fuel cells. They call it sugar-free, subsonic ultra-green aircraft research. But in order to get to the 40s, what do we have to do now? What are the aviation industries doing now? They're not looking, they know that they have to replace kerosene with some other fuel. But the easy answer is to use a drop-in fuel. By drop-in, they mean something that can be put in the same tank of the existing. And that doesn't only apply to aviation. Of course, it's also for our ships and of our trucks. The easiest thing is to put a biodiesel or an ethanol or an ethane gasoline. Is this really solving the problem? It solves the availability. For example, in South Africa, they make synthetic kerosene from coal. That's the old German technology, Fischer-Tropsch process. So all the aircraft landing in Johannesburg out and in Cape Town, they refuel with the kerosene made out of coal. Very pure, very good product. And also the cars driving in South Africa have quite a substantial quantity of fuel made out of coal. But that is particularly because of the abundance of coal in South Africa. In Qatar is another matter. They have gas. So they convert gas to liquid. GTL technology is the same technique. Instead of using coal, you use gas. And if you don't have gas and you have biomass, you make BTL. You make synthetic kerosene out of biomass. This is where the industry is driven right now because the biofuel is the renewable source that would be replacing the kerosene in the future? Not really. We don't have that many resources of that. And one last development is the conversion of the vegetable oil into hydrogenated kerosene. This is a refinery process. It's just hydrogenate the biodiesel. These solutions are not sustainable from an environmental point of view because the emissions are higher of the normal kerosene. Also, because the energy required to make these processes, it's higher, just refining crude oil. So, what other option is available? It's an option that we call not drop-in. We cannot mix LNG with kerosene in the tank, but we can mix it in the burner. The aviation industry is looking seriously for alternative to oil. We want to reduce 50% the emission of CO2 by 2050. How do we do that? We believe that this is a solution. This program was started in 2010 with the financing by the German Ministry of Economics, and we participate with two companies. One is TG and one is LNG. Lufthansa is not supporting our unit because they support the hydrogenated vegetable oil. The research phase is being completed. The next phase would be to use the LNG for the auxiliary power units, then go to the power plants, and eventually to the new design. The target was to have the possibility to use LNG on the existing aircraft, not wait 40 years for the new aircraft. How do we do that? Four phases. The first phase was just to prove that the flame characteristics of methane are more similar than kerosene to hydrogen. This might be immediate, but was one of the main concerns that we could not use methane in replacement of kerosene in the existing turbines. Strangely, because the gas turbines are designed for gas. They've been using kerosene just because gas could not be carried. The second point was to have a cryogenic tank powering the auxiliary power unit, and already today we put kerosene in the auxiliary tanks that are similar to those that load the cargo. That is to extend flight. So we have designed LNG tanks that would be fitting into the LD6 container size in order to power the APU initially, and if we put a relevant number of these tanks in the bottom deck of the aircraft, we can fly even 5,000 kilometers. That is a temporary solution, feasible because today you don't load cargo in the passenger flights. So the cargo space is empty. And in the cargo flight, that would mean a 20% cargo reduction. But sometimes the cargo limitation is not the volume or the weight. And this is just an interim solution to show the possibility of using LNG. By the way, the fuel cost today is one of the main components. And by using LNG, we can save about $20,000 per flight on the international flight. That would be quite a significant saving. Finishing. Let's compare. Drop-in versus non-drop-in. Upstream versus downstream. Is it true that in order to change the downstream infrastructure from oil to gas, we have significant investment to be done? But let's not forget that in order to make synthetic kerosene or synthetic fuel out of oil alternative like coal or GTA or gas or biomass, there are significant investment that needs to be done on the upstream industries and in the refineries. The two in order of magnitude are in the same order of magnitude, with one difference, that the drop-in solution are not at a lower cost compared to oil. They are sold at a premium. While the downstream LNG solution are sold at a discount compared to oil, which means that from this discount we can finance the development. And this was already mentioned by some of the previous presentations. I'm concluding. Coal was the driving force of the Industrial Revolution in the 19th century. Oil has been the new revolution for sustainable mobility in the 20th century. But now, oil, it's shifting to gas, and we believe that gas is the sustainable fuel for this century, and it has already started 10 years ago. So we need innovative solution, and I'm also convinced that we also have to innovate our way of thinking. Until now, we have bring in LNG from remote location via terminals, but a new solution also following to the price change and the availability of gas is to make LNG on site and liquefy LNG from the pipeline. We believe that this is an innovative concept that is coming, and we have already activated this kind of process. Thank you.